At 6:05 a.m., air defenses surrounding the Progress missile factory came under a coordinated unmanned aerial vehicle assault. The first surface-to-air missile launched into the frozen morning air and intercepted its target 3 kilometers out. Within seconds, additional launches followed. Radar operators tracked a rapidly filling corridor as 41 low-flying UAVs approached at approximately 210 kilometers per hour, flying at treetop level, with radar signatures barely larger than migrating birds. Individually, the drones were inexpensive, estimated at around $34,000 each. Collectively, they posed a saturation threat. At low altitude, radar detection range shrank from nearly 30 kilometers to approximately 12 to 14. Ground clutter from buildings, frozen rivers, and power lines further complicated target identification. Defending batteries, fully loaded with 48 interceptors costing close to $175,000 each, began sequential engagement cycles averaging 6 seconds per firing sequence. In less than 15 minutes, millions of dollars worth of interceptors were launched. Each engagement was technically precise. Targets were tracked, firing solutions calculated, and impacts confirmed. However, the drones arrived in staggered formations from the north, northeast, and northwest, forcing continuous sequential responses and steadily reducing missile inventories. By 6:20 a.m., 13 UAVs remained airborne under 30 meters altitude, approximately 12 kilometers from the factory. Pantsir S-1 air defense batteries continued intercept operations within expected performance parameters. Drones were destroyed at distances of 9 and 7 kilometers. Engagement cycles remained between 6 and 8 seconds from lock to impact. Despite operational effectiveness, interceptor inventories declined rapidly. Some batteries reported single-digit missile counts remaining. At 6:28 a.m., after multiple successful interceptions and limited short-range gun support, the first UAV breached the outer boundary fence. With no interceptor immediately available, it struck the roof of an auxiliary assembly building and detonated, igniting secondary fires. A second UAV impacted near a storage facility adjacent to a rail spur. Internal suppression systems activated, containing the fires, but production halted as emergency crews responded. 2 structures were burning, and sections of the facility were compromised, though the factory remained standing. By 6:34 a.m., radar detected a new formation entering the corridor. 4 heavy strike drones, flying at approximately 330 kilometers per hour and cruising at 150 meters altitude, were closing in from beyond 20 kilometers. Each carried an estimated payload of 70 to 75 kilograms and had a range exceeding 900 kilometers. Unlike the initial wave, these platforms were built for deeper penetration. Interceptor counts across the sector had fallen below 10. Command units faced prioritization decisions as the heavier drones approached. The defensive network remained active, but missile inventories were critically low. Smoke continued to rise from sections of the Progress facility as the situation evolved from an initial saturation drone assault into a second, more substantial threat phase. As the second formation advanced, the air defense network faced critical resource constraints. Fewer than 10 interceptors remained available across multiple batteries as 4 heavy strike drones closed within 20 kilometers of the Progress missile factory. These platforms were traveling at approximately 330 kilometers per hour at an altitude of 150 meters, each carrying an estimated payload of 70 to 75 kilograms. Their range exceeded 900 kilometers, indicating capacity for deep penetration beyond the immediate target zone. At 17 kilometers from the factory, radar operators observed unexpected deviations in the flight path of one incoming drone. Its heading shifted several degrees east before drifting further off course. A second drone displayed similar instability at 14 kilometers. Telemetry data indicated navigation disruption rather than mechanical malfunction. No interceptor was launched during this phase. 5 kilometers west of the factory, a mobile electronic warfare unit had been operating since before dawn. The system broadcast across a wide frequency band, ranging from approximately 100 MHz to 2 GHz, saturating satellite navigation signals within a 30-kilometer radius. Inside this zone, global positioning accuracy deteriorated rapidly, with positional errors compounding from tens to hundreds of meters in seconds. By 6:38 a.m., 2 of the heavy drones lost stable navigation and descended into open terrain outside the industrial perimeter. A third veered off target and impacted beyond the factory boundary. millions of dollars in strike capability were neutralized without additional missile expenditure. The defensive network temporarily stabilized, and the factory, though damaged in earlier strikes, remained operationally intact. However, radar tracking confirmed that not all threats were affected. At least 2 heavy drones maintained steady headings and consistent speeds of approximately 320 kilometers per hour while holding altitude near 140 meters. Despite operating within the 30-kilometer interference zone, these drones showed no signs of drift or navigation error. Spectrum analysis confirmed that the electronic warfare system continued broadcasting at full strength, saturating frequencies between roughly 120 MHz and 1.8 GHz. Operators assessed that the remaining drones were not dependent on satellite guidance. Instead, onboard systems relied on terrain-referenced imaging and inertial measurement units. Downward-facing optical sensors compared ground features, including roads, rivers, and rail lines, against preloaded satellite imagery. Position updates occurred at short intervals, with inertial drift measured in fractions of a percent per kilometer. Electronic interference had no measurable impact on their navigation. At 9 kilometers from the factory, one drone executed a programmed heading adjustment, confirming route correction rather than signal loss. By 7 kilometers, both descended to approximately 120 meters. Radar tracking indicated convergence not toward the factory complex, but toward a location 5 kilometers west, the position of the mobile electronic warfare unit itself. The jamming vehicle had been emitting across the electromagnetic spectrum for nearly an hour. Its coordinates were exposed through continuous broadcasting. The unit possessed no kinetic intercept capability and relied entirely on distance in signal saturation for protection. As the drones closed to 3 kilometers, optical systems transitioned from terrain matching to object recognition, aligning visual confirmation with stored reference imagery that included truck chassis, antenna arrays, and support trailers. With no interceptors remaining within effective range and no defensive gun systems positioned nearby, the electronic warfare unit was left without immediate protection. At 2 kilometers, both drones accelerated slightly during final approach. The jamming signal remained active at full output until seconds before impact. At 6:53 a.m., the first drone collided directly with the electronic warfare vehicle and detonated. Moments later, the second struck the adjacent trailer. The broadcast signal ceased instantly across the corridor. Satellite navigation stabilized within minutes. Cellular networks that had been suppressed for months across the 30-kilometer radius resumed normal operation. For the first time that morning, the interference field was gone, and the regional airspace and communication spectrum were fully open. At 7:12 a.m., approximately 19 minutes after the destruction of the mobile electronic warfare unit, a fuel convoy entered the rail junction west of the Progress missile factory at a speed of about 60 kilometers per hour. The train consisted of a locomotive followed by 14 tank cars, 11 loaded with refined fuel, and 3 carrying compressed gas. The total cargo weight exceeded 850 tons. The junction represents a critical single-track choke point through which nearly half of the region's fuel supply passes each day. Beneath one section of ballast between steel rails and gravel, a compact improvised device had been concealed for weeks. The device consisted of a commercial mobile phone connected to a triggering mechanism. It required no satellite uplink and no remote operator. Its activation depended on a single condition: successful registration with the nearest cellular tower. For months prior, that registration had been impossible. The electronic interference system, operating within a roughly 30-kilometer radius, had suppressed satellite navigation and cellular bands, causing calls to drop and blocking mobile network access throughout the corridor. Inside that interference zone, the concealed phone remained offline and inactive. After 6:53 a.m., when the electronic warfare vehicle was destroyed, broadcast suppression ceased. Cellular towers across the region resynchronized. Signal strength was restored. Civilian devices automatically reconnected to the network as service resumed. As the fourth tank car passed over the concealed section of track, the buried phone completed a brief cellular handshake with the nearest tower. The trigger activated immediately. The rail fractured under the moving convoy. Momentum carried the train forward, placing strain on steel couplings that failed in sequence. Multiple cars derailed, several tankers ruptured on impact. Spilled fuel ignited, producing a large column of flame visible for kilometers. Emergency response units arrived within minutes. but the single-track junction was heavily damaged and blocked by derailed rolling stock. Traffic through the corridor stopped completely. By sunset, smoke above the rail junction had diminished, but the operational impact continued. The Progress missile factory, though damaged earlier by UAV strikes, remained standing and operationally intact. Air defense units had intercepted dozens of drones, and electronic countermeasures had initially disrupted heavy strike platforms in accordance with established doctrine. However, the supply corridor west of the factory was severed. The sequence of events, saturation drone attacks, depletion of interceptor inventories, activation and exposure of the electronic warfare unit, destruction of that unit by navigation-resistant drones, and subsequent restoration of cellular service, resulted in the triggering of the concealed rail device. The morning's events demonstrated that the initial aerial assault extended beyond direct structural damage to the factory complex. While interceptors were launched on schedule, targets destroyed, and electronic warfare systems activated as required, the cumulative effect of those actions led to the reopening of communications networks. The rail disruption halted a significant portion of regional fuel transport. The engagement highlighted the interconnected nature of air defense, electronic warfare, navigation systems, and civilian communications infrastructure. Operational decisions made in response to immediate aerial threats influenced broader system stability across the region. The factory remained functional, but the supply corridor faced prolonged interruption following the derailment and fire. Emergency services continued response and containment efforts at the rail site. The junction remained closed, pending clearance and structural assessment. The events of the morning underscored how sequential actions across multiple domains, air, electromagnetic spectrum, and ground infrastructure, combined to produce consequences extending beyond the initial battlefield area. For continued coverage and in-depth analysis of strategic developments and modern warfare systems, subscribe for further updates.